guys, my name is Vishal Gupta. I am president of IOSC BVP, and IOSC BVP is a technical society, and I'm heading that. And we have different domains, including AI/ML, in which we make projects and learn together. So pretty much that. I'm also a top machine learning voice on the LinkedIn. So I know, we're gonna have fun in this session. So we'll be starting. Today's agenda is introduction to Azure AI. So, for the audience, I know that I have asked so many of my juniors to join today. So, I will be covering this session in the two halves. The first half will be a basic AI ML related things. So, everyone will get on the same page. The second half of the session, we will be going about the Azure AI because we are here today for the Azure AI, right? So, let's begin, right? Okay, this is the attendee survey. I have also added in the last slide. I request everyone to scan this and please fill up the survey. Right, we will love to know the feedback. We will go in the end of the session. Okay. So here's one joke for AI. Can't AI write the talk for you? I mean, in today's time, we are doing everything with AI. From a child in a school writing his assignment homework to a research scholar who is writing his PhD thesis and all that with the AI. So why can't this talk with be written with the AI, right? So I have used AI, but it's for you to decide what is written with the AI or not. Okay, let's begin. So as I said, the first part will be about the AI, and the second part will be about the Azure, right? So this is something that everyone in the machine learning industry will have know about. Like if you are practicing machine learning, this is something this the first thing that have been taught to you, or you have seen it at many places, any books or any material that you have referred. These are the layers of machine learning. So what it says is we have an outer layer which is artificial intelligence, in which machine learning is a subset of artificial intelligence, and deep learning is also a subset of the machine learning. I mean, you can see it like a melon, right? It's a roll, and I mean down it have a seeds in it, whatever you want, and also it's like the earth, right? Earth, then core, then crust, whatever you want to say, crust and core, and mix them. But the thing is, the machine learning is a subset of AI, and deep learning is a subset of machine learning. But there is one more thing that is not depicted here: is the generative AI, which is a subset of the deep learning. I mean, you have to have the understanding, the differences in this, so you can continue forward. I'll try to explain things with examples, like what is the artificial intelligence, what is machine learning, what is deep learning. Starting with the artificial intelligence, it's the superficial layer, right? I mean, what do you think about the artificial intelligence? It's the intelligence of something, right? We can say, let's say as an example, let's take a student example. Let's say one is a Ram, another is a Sham. Their math teacher taught them about the addition today. What they taught, what the teacher taught is that 2 plus 2 is 4, 3 plus 3 is 6, and like 4 plus 4 is 8. What Ram did is Ram memorized everything. Now he knows what it will be. Sham learned the concept, what this plus means, what is happening behind the picture, what this addition 2 plus 2, what this means. 2 plus 2 means we are adding this. This is 4. So Sham did this. The next day they goes to the school. The teacher said, "Let's have a test." The teacher gave exactly the same question she taught. Right? Both had done excellent in the exam, and they got the full marks. Obviously, because they know the answers. The other day they went to the school. The teacher said, "Let's have one more surprise test. Let's see who can do this." And this time, teacher changed the question little bit to test their understanding. What she did is she write 2 plus 3, right? 3 plus 4. I mean, from our perspective, it's not a big deal, but for a like third class student, it's a big deal, right? So what Ram did is Ram memorized everything as it is, like a picture, like 2 plus 2 is 4. Yeah, he knows that line. What Sham did is Sham knows what plus operator does. So here, when they are doing the test, Sham did it. We know he knows the concept. He can do this. But what Ram did is, what Ram thought 2 plus dash equal to, I mean, he memorized something, 2 plus something is 4. Let's write 4. 3 plus something is 6. Let's write 6. 4 plus something is 8. Let's write 8. He write that. And the result day, we all know what gonna happen. Ram got disappointed. What happened? Right? So what happened here is Ram just memorized everything. He didn't use his intelligence, or he didn't get the grasp of the concept. But whereas Sham did is, Sham knows what happened behind the concept. What is plus operator doing? He now has this intelligence that if I write this plus this, then he can write this. So if I give Sham that 2 apples plus 3 apple, what will be that? He can tell that it will be 5 apple. But I will give it to Ram, he will be confused. What apple? Apple? What? I just know 2 plus 2. Right? So this is intelligence. When you teach something to a computer, let's say I teach that, let's say a computer, that this is a water bottle, but I didn't tell other things like this is a phone. He don't know. So this is more like that, having a database that you know this is fixed. But you, if I am coming out of the box, you can handle that. Like I have multiple pens, but I told Ram that this is a pen and this is a pen. But what about this red color? What is this? This is a stick or something. Sham knows that is a pen because it has a shape, it had a definite density. We can write from this. But Ram says that it is not a black. It is. I can see it is very. I mean, they have a weight, but this is very thin. So I don't think it's a pen. So this is intelligence. That I taught you something, but you can use that knowledge in some other ways. Right? I told you there's a plus operator, but you can use that plus operator elsewhere also. Moving. So if I say example of artificial intelligence, you are using it daily, and which is Alexa. You ask Alexa, how's the weather? I mean, I'm having a conversation with a machine like just like a normal human, right? What's the weather today? And she replies efficiently. So this is artificial intelligence. But if you get in depth of that in artificial intelligence, the behind the scene is machine learning. And what machine learning does is, machine learning is help to predict and identify patterns. Okay, I will go through an example. You will understand better. Let's say I have a business of cotton cloths, like we are wearing right now cotton cloths, and I give it to you that find when I have the like good sales, what is the best time should I sell my clothes and all that, right? So I watch over my past details, past history, and all the sales. I found out that in the summer, my um, we can say the I am selling more in summer rather than winter. And you know, obviously, because we wear cotton cloths in the summer rather than winter, because we wear woolen clothes in the winter. So you give me insight that you should sell more in summer and like slow down in the winters. Don't buy too much of stock or something. Just buy too much in summer and put it on sale or something. Well, that's something I can tell without his knowledge. Right? I can tell that my shop, it is my shop. I know when I'm earning much, I'm earning less. So what here had machine learning? So I tell you a recent, I mean, it's not recent, it's I guess 2017 study. One data scientist took the all the sales of the Walmart, okay, and he studied his all the data and historical pattern. You know what I find out in that? He saw when the hurricane came in the specific city, let's say any city, there's specific product in the Walmart which sales goes high. I mean, what do you think? In a hurricane, in a problem, in I mean in a in a hurricane, it's a you should be thinking of your life, right? What the thing that you want in that time? It can be like rope or some like supplies, medicine, something, right? But what data implied is there's a specific kind of muffin that that sales going high during the hurricane. I mean, how people are buying muffin during a hurricane? Like that's not. our thing to know that data is telling us that muffin sales is going when the hurricane came. So these kinds of insights help us business to understand them and increase their sales. These are the application of machine learning. So now what Walmart can do is they can stock up more muffins when there's a warning of the hurricane, and they can increase their prices obviously, because data never lies. If data said that this is going to happen, then this is the most probably going to happen, if not an unexpected reason has happened. Okay, so if I summarize what machine learning does is it help you to identify patterns in a historical data and let you make informed decisions on the basis of that. Right. Up now coming to deep learning. I mean, in these three layers, the most interesting is deep learning. I mean, if you start learning machine learning today, you will be more excited about the deep learning because it has like voice recognition. You can speak in like Shah Rukh Khan voice, or maybe you can just identify faces. You can make face identification systems, whatever you want. Right. So it's most interesting. But yes, it takes lots of math behind the pictures, things, so much is there to explore. Right. But what's the difference between the machine learning and deep learning? But deep meaning only the word of the machine and the deep? No. Actually, deep learning takes a raw input of data. Like deep learning is like I'm sending this image. I will just take the picture of this bottle and just sending it to deep learning model. This is the very raw image. But in a machine learning, I will be giving a very pre-processed data. I mean, I will give you like let's take example of match right now. A match is going on, right? So I'll take Virat Kohli and I'll take every single day match, whatever he played so far, and um, his whatever his run rate he made in every match, and give it to machine learning. So all the run rate should be in a specific format. Like if it is a floating value, they all should be in the floating value. So it should be all processed data. There should be not missing value or something. So I have to send that in machine learning. But in deep learning, we don't have to. We actually send, we don't use number data actually, because I will come to that later part. In deep learning, we do complex computations. Like we are sending images of the cricket team members and ask machine learning model to identify who are who. So I mean, how this machine knows, yeah, if this is an image of the Virat Kohli or something, and sometimes the photos are from different angles, sometimes their face are covered, sometimes you are not going to recognize it, but we have come to this point, this accuracy that a machine can identify that. Right? If you heard about the YOLO V8 models, YOLO V10 has come. So if like something as here is an object on the Virat Kohli face and he is looking like that, and if I click the image from here, it can still recognize it's a Virat Kohli, and sometimes you missed it. So that's the power of the deep learning. So, okay, so summarizing, AI is mimicking the human behavior. Machine learning is like predicting the future and finding pattern. Deep learning is, I mean, we can say having complex computations and all that. So these are the layers of the machine learning. This is very important if you don't know about that. And now I just want to give you overview. Like these are the key elements of AI. And what is AI? AI is a software that imitates human behavior and capabilities. So you can see like machine learning. What machine learning does is learn and predict like human. It does something like human. Anomaly detection detect things out of place like human. Let's say, uh, in a cafe, there's a horse standing. You can obviously tell na, ki, why is there a horse? Yeah, is he here to drink coffee or something? So it's anomaly. It shouldn't be here. So we have this type of things that we can make that detects anomalies. It shouldn't be here, but why is it here? So that's a problem. Put it out. Other thing is computer vision. Computer vision is like able to see like human. So like you can use computer vision models to see like human. Like I can recognize this is a mobile phone. I can train my computer to recognize and see where is my phone. I will just put a camera upside something and it will scan my room and find where the phone is. I mean, how amazing that! My laptop can do my all the things that I can. Yeah. So natural language processing, like you already using chat GPT on that. I mean, who thought that someday I will write something to the computer and he will understand it and reply to it also. I mean, I write me a paragraph, write me a story for my girlfriend or whatever. He will write it. And how amazing that, yeah. Who thought someday that will happen? So natural language is processing is saying that it will whatever in language I will write, it will understand it and understand the context of it, and I can then have conversation with it. So there's a conversational AI also that holds conversation with the human. Like I'm having conversation with you guys, and they can also have conversation with. Okay. These are all the elements of AI, and that like all are similar to the human behavior. So I will be introducing like for an example of AI, meet our new friend Chitti. You have already met in the robot movie. So it works on the AI, right? Alexa is also AI. Lots of things are there. The Tesla car is an AI. You know, we say there's a AI technology in our ACs. So what they do is they do something like that mimics human behavior. So if I say AI AC, so what it will do is once the temperature reaches the desired temperature, it will stop cooling. It will just maintain the temperature. And if we go past, then when the AI technology is not there, so what happened in AC, it will cool till that temperature and then shut down. It don't do any cooling or something. It just stops. And when the temperature lowers, it will start cooling again. So this happened in previously, but AI, what does AI is once the temperature room reaches the desired value, it will just maintain. So this is AI. Chitti is one of the example of the AI. It can do lots of things like AI. I mean, it's more than AI, but okay. Now we know what is AI. We have understand machine learning. Machine learning help computer. So let's take a step back. What is machine learning? You say machine learning. I mean, learn machine, yeah, machine को सिखाना, right? So it's a way. What happens is humans are the laziest creature, and we don't want that we do the repetitive work. I don't want to like do same type of work every day. If I know that we have to do this in a this specific manner, like let's say I have to create a report of everything that I have done today. So I have to write all the things, then I have to think about it, then write the report. I can just say to the chat GPT that, yeah, I did this project, I did this project, and write a report. See, so this is machine learning. I mean, I gave you a different example, but okay, never mind. So basically, this is that I am explaining my computer that, yeah, let's learn this, and you will do it for me. Okay. So machine learning is three types. One is supervised learning, unsupervised learning, and reinforcement learning. What does this mean? Supervised, unsupervised, reinforcement. What is this? I mean, supervised learning is where you have a teacher. And teacher. Okay. Let me give you an example. In your home, let's say there is a baby of 5 year, 3 year, let's say. Okay. And he likes eating apple regularly. Now his mother takes an apple and every day came to the baby and say, "You wanna eat apple? 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 You want apple?" So after a certain time, the baby start recognizing what is an apple. So if she says, "Okay, get an apple," he can run and get apple from wherever he finds, right? Because he know it's a red color, round shape with a stick on it. It's an apple. But if I say, "Okay, bring the mango, bring the orange," he don't know because he never seen it. Similarly, in supervised learning, we give some correct. We train someone. Let's say we have a chitti. Chitti is not programmed yet, and what we do is we give him a character. Let's say we take example of this. Okay, we say something is cylindrical, have a cap on it, and it's, I mean, hard, can store something. Is a bottle. Right? I told chitti this much. Now he finds something container or something. Let's say some kind of box, which is a which is hard, which has a like lid, and I mean cylindrical. So now if I ask Chitti bring the bottle, it's a chance that he will bring this or this, because we trained him on this specific characteristic. So what I want to tell you is, when the baby seen enough times something, he can recognize that. Similarly, if we tell our computer something enough times, he can understand that, right? He can understand that. I mean, I know that's something crazy and also scary, but yeah, that's true. So what we did in machine learning is, we give a lot of data of something and try to and give it to machine learning. Let's say this is a machine learning, this is my input, I give it to machine learning. Whatever you do, you memorize this, you find pattern, you learn it, then it's a ready model. I will give something new and it can tell me what is it. So if let's say, let's take example of baby again. We are little short on time, but okay. So let's take example of baby. I showed baby three fruits: apple, mango, and orange. I showed him apple. Okay, this is red, round with a stick on it. Mango, it's a oval with a yellow color and sweet with a sweet seed inside. Orange, it's like little, bitter. I mean, have different peels, orange in color, whatever it is. Now, whenever I ask the baby to bring this fruit. Let's say I say bring something that is red and round. The baby can recognize, na? Because he learned it. He knows that pattern, that red, round, and something. This is apple. And if I say bring something yellow, he instantly knows that yellow and the oval shape is orange. Let's say we are two are playing games, and we are here. Let's play a game. Let's play a game. Which fruit is this? Okay, you tell me. I'll tell you the characteristics of the fruit. It's has plant on it, and it's very spiky, but it is very, I mean, sweet and sour in taste. It is yellow inside, but outside it's very spiky, right? You can imagine a plant, a round shape, a spiky. So it's most probably pineapple, because you have seen it enough times, you have memorized it, you know how it looks, you can tell it. The teacher, what I am telling is supervised learning. The teacher is so okay, we'll deep dive, we'll come to this later. But okay, supervised learning is where we have the labeled output, where we know the answer. Unsupervised learning is where we don't know the answer. So let's take the example of Shinchan. I was just watching it tomorrow. Okay, don't judge me. But yes, so it's a very great example. If you watch Shinchan, you will see his room is very messy, right? He has books. I mean, not books, but let's take hypothetically, he has books in his room. He has ball in his rooms. He has action Kamin and other toy figures in his room, right? It's all messy. His mom came in the room. Okay, what is happening, Shishan? Why are you like this? Clean this up. Okay, if you don't clean in 5 minutes, I will throw all this outside. Done. Shinshan got scared and just put it everything in the box. Now her mother came. Wow, you cleaned it. My God. You see, okay, there's a only single blocks filled up, and she checked. Okay, you have put in your brooks all everything here. She punched him, right? She gave him a negative. You can say it's a punishment, right? And now she asked him to clean the room again. This time, what Shinshan does is he didn't thought about it, but he's actually doing clustering. What he's doing is he's making balls. We have all the things that are round are characterized as balls. So he put all the balls in a one box. He put all the action Kamin figure and all the plastic toys in one box, and all the books in a other box. He intuitively done is clustering. He put same type of cheese in one box, other type of things in other box, and other type of things in other box. But here what happened is he didn't know, if let's say if for a machine learning model, if I asked him the same thing, the machine learning model won't know about this, that this is a ball or this is some. He just do is that all the round objects should go in the one place, all the books should go in the one place. Books, I mean, all the rectangular heart with the pages inside should go in a one place. So this is unsupervised learning, where we don't know the answer, and but we can characterize things in a group using same characteristic. Like if I say place bottles, all bottles in the fridge, you know that all the things that look like this should go in the fridge. Similarly, all the phone should be put up in the charging. So everything that look like this should go in the charging. So this is unsupervised learning, where you don't know the answer, but you can think is it like the similar thing goes in one place. Similarly, reinforcement learning is very interesting. I mean, Shinchan mother punched him because he done something wrong. Wrong. So this is a punishment. And when he cleaned the room his properly, he gave his favorite snack. That is a plus point. Similarly, machine what like Chitty, if there is a Chitty robot. So what he does is, if I ask him to bring me water, and we bring me Pepsi, so I just like scold him that why did you bring this? This is wrong. So what he did in his mind or back end is that he gave him a punishment, let's say, and make changes. Whatever the thing is that I will never bring if he asks me to bring water. Next time he bring water, I will get okay, great one. So he will give him his like plus points. That okay, thank you so much. Okay, this is the thing. Whenever he says that brings me water, I will bring this thing. So this is reinforcement learning, that learning from mistakes. Unsupervised learning is learning without knowing the answer. Supervised learning is learning while knowing the answers. These are the three types of learning. Let's go into more depth because we don't have that much time. So these are the famous algorithm. One thing that you really see in today's world is that you receive thousands of emails regularly, right? And your Gmail specify it is a spam email or not a spam email, so it will categorize on its own. So it's simply like mango or an orange. So it's classifying. So it is a supervised learning because we know the answer. Regression is an example. I hope you can see my mouse. So let's say I take Virat Kohli scores on the left side y-axis, and on the right side I take days, day 1, day 2, day 3. Now on the day 5 I can predict actually how that is. We put the scores on the graph paper, and we make a best fit line. Best fit line is possibly the smallest distance from all the points. Okay, so there is a best fit line, and on the day 5 I can just check where the line that will intersect, and I can get the score. So this is regression. There is a classification. Both are the supervised learning because we know the some kind of answers. In classification, the answer is in yes or no form. Regression, we get a value, something like an integer, a number, right? In clustering, it's like making two things separate. Like balls have a separate box, and action common figure have a different box. So we are making two clusters, blue and yellow. Okay. Now in deep learning, we use neural network, and I mean, it fascinates me how the scientists discovered it. Scientists saw the neuron in our brain. It looked like this. You have seen in your bio books in class 10th or something, in where dendrites sense the signal, and whatever it is, it transport through axon and finally transmit the signal into axon terminal. Right? That's how neural network works. Similarly, scientists made neuron that you can see the circles here, which take some input, whatever you want to do some computation in the hidden layer, and give you the required output. That's it. And you don't have to worry about the hidden layer, what's happening inside, but it's just you take care of the input and the output. That's it. The like chat gpt does this, and I mean, whatever the textual thing, like I give you a book summary and ask you to summarize it, so you can use neural network to summarize it. Now, okay, Vishal, we have learned about the learning technique, whatever. Okay, that's it. We don't want to learn anymore. Okay, we get the idea. But how this model will we make? How we can make this? So there is a proper way you make this model, and this is the. I mean, this is what industry uses. What we take is, I'll just make it simple for you. We take data. We choose the like data labeling is we are taking the data. Feature engineering, we are taking only the important data. Like if you have it date of birth and all that, maybe that won't need it. Yeah, customer ID, we don't need to predict something, right? So we take data, we take important features, we train our model on that data. Like we saw this laptop, all the images of the Apple and all that. Then we check our model, that how it's performing. Is it a good model or a bad model? Then we, according to our needs, if it's a bad model, we change something in the model that you should learn more. So that is hyperparameter tuning. Then we just ready to serve in the like production, and we can just like make a real time endpoint. And I mean that's not needed at that place, but you can like use, you can create an endpoint like API type, and you can use it in the production, or you can just make a model and that will keep learning. Okay, so that's not needed. But main thing is we take data, we choose features, we train the model, we evaluate the model. So how evaluation happens is there are lot of matrices. I mean you don't have to know everything, but yes, the main thing is that you will be working is classification matrices like accuracy, precision, recall, F1 score, ROC, AUC, and regression metrics like MSE, RMSE, MAE. So these are the metrics that you will see. These are just the names that you are thinking that too much. Like accuracy, you know how accurate it is, how precise it is, how recall is something that we can take later. And mean square error, that you have square like it's a mean of error, but the squared errors. So it's something like that. You don't have to worry. And like I can see how many we are here, but let me tell you this. There's an exam from the Azure AI 900, and they asked this matrices, like what are the regression matrices. So you have to know RMSE, ME, MSE, only the first two lines. Okay, and this is something. This is we call as confusion matrix. From this we calculate all the matrices. Right. Okay, we have to. So this is just a metric, say like actual value, like we can say it's a metric like what should, let's say take an example of healthcare. There is a classification. Let's say that I have a heart disease or not. We have to predict this. Okay, we make a confusion matrix where what happens is we put actual values on the upper side and the predictive value on the left side. Positive means that I have heart disease, and negative is I don't have heart disease. And predicted value is also this. Positive means that yes, that model predicted that I have uh, heart disease, and negative means that it predicted that I don't have uh, heart disease. So there's all the combination true, positive, false. But I mean, this is like actually positive and predicted also positive. So this is true positive. True positive is that I have heart diseases and my model also predicted that I have heart disease. So great. Negative is that I don't have a heart disease, but my model predicted positive. That means this is I don't have any heart disease, but this is predicted that I have heart disease. So this is a problem. So I mean, all these things will use in a formula to calculate the recall score, F1 score that you can study later, but you should have an idea. Now here the thing is from the like Azure AI. Though you have completed the machine learning part, I will take little fast. Responsible AI is just the things that you should make sure when you are creating an AI technology. I mean, this is something that Azure AI fundamental exam definitely asks you. What are the responsible AI principles that Microsoft follows? So it's nothing. It's like ethical and transparent and accountable use of AI technology. So as you know, in the Chitti movie, there was concern that the Chitti will harm people, right? So it should be, you know, it's a principle of AI that it should be safe, right? It using a lot of data, so it should be secure. So these are simple principle that Microsoft says that we should follow, but it's not standard, but it's good to follow. Like first is fairness, that everyone should be equal treated. Like in hiring, there should not be any kind of biasing regarding genders or something like uh, I can say caste and other things. Reliability and safety, that your model should be reliable and safe, like health diagnosis. We are diagnosing something and it's giving something. I mean, let's say I don't have a cancer, but your model predict that I have a cancer. I mean, I am gonna die just thinking about that. So it should be reliable. The other is privacy and security. So machine learning is ChatGPT, it holds too much of data. Like a lot of companies are using it, but it should not leak that data. So that is privacy and security. Inclusiveness, that it should empower everyone and engage people. That's obviously clear. Transparency, that whatever we build is, it should be understandable by the people. Accountability is that people should be accountable for the AI system. Like we have made a chatbot for our organization, and obviously it should follow some organizational principles, so something like that. So these are just principles that we should know. Now comes the Azure AI. I mean, what have made this by the Microsoft? Sometimes I am scared of Azure. I will tell you. So Azure is a cloud-based platform, and it provides so many services, AI services, which they call as cognitive services. So cognitive services like a bigger umbrella, which has different services inside it. So it's a family of AI services. We will talk about this. So cognitive services are services and cognitive API to help you build intelligent apps. You can just build apps whatever you want using these services. Nothing, you know, nothing surprising. But let me tell you the surprising factors. There we have already pre-trained models. Like I have already made a object detection model that can identify bottles, a plant, or something. You can use it and uh, pre-train. You can, that we call this pre-train, and you can use to identify, let's say, cars. You can just customly train it. That you can also train an already trained model on a different data set. Okay, so first thing is a customize and pre-trained model. Second thing is Azure AI help you in the deployment. You can deploy in the containers. I mean, that's also one thing. But I mean, if I just put in an easy word, that deployment is easy, and it can be done in the containers, and that container can be sent forward to anywhere, and that people can use it. And the best thing is you don't need an ML expertise to build apps. Amazing that you should know, don't need to know everything about the ML that we have talked so far. That will be more than enough to build apps on the Azure AI. So that's great. One thing that I explored is there's a, I mean, Canvas, Azure Canvas or something, where you can actually drag and drop things and create models. I mean, that's the thing a kid can play with, right? So that how things are there. And also, if you're using AI as your AI service, it will follow ethical standards. Like you don't have to worry all the responsible AI principles or all that. It automatically strictly follows them. Okay. So I have added this all the service. I'll just give you the important that I feel fascinating, like speed to text. You can make a speech into the readable text. Obviously text to speech, speech translation, one speech into other state, real time hota hai wo bhi, right? And vision also, there are different type of computer vision, custom vision, and face detection. So you, they have already have pre-trained models. You can use them very efficiently, very easily, and you can have your model ready. Similarly, a Q&A maker, text analyzer. I mean, text analytics is really great. They have this key phrases, named entity, detect sentiment. Like I give a text, uh, I give a text. Sorry, I will give a text to a model, and it will detect it's a sad emotion or a happy emotion. Like we do, Amazon do this on the customer reviews for the product. It detect that a person is happy from the services or not, something like that. Key phase extraction is like I have a paragraph, and it will extract some important things. Named entities, I mean, amazing. It extracts like the let's say we have a form, and it has a company name and all that, whatever it is. It can extract specifically that for you. So I mean, that I find really amazing. So these are all the things that you can build. I mean, Azure OpenAI services. One thing is, so Azure OpenAI services is, they are using OpenAI language model like ChatGPT and all that, and um, integrating it with their own cloud infrastructure. So Azure has a very great cloud infrastructure, and they are integrating with it. So let me show you. So Azure AI services is a cloud-based platform for development and management of the language model from OpenAI, right? So you already know the chat GPT is 4. Here is, well, it's introduced for the public. So what it can do is, it is originally made for multiple tasks, but main thing is to have a conversation, uh, generate text, or maybe programming codes, right? Similarly, a lower version is chat gpt 3.5 model. What it does is, it also does the same programming code, can write. But there are also chat gpt 3.5 with 3.5 turbo, which is specifically made for the conversational ai, to have a conversation, so you can use in a chatbot or something. So these all are the models that as OpenAI develop, and Azure is integrating with its infrastructure to give you a more intelligent app that you can build, right? The other is embedding model. So embedding model is used in like neural, say computer vision and all that, in where we have to convert, also NLP, where we have converted text into embeddings. I mean text into, if you can say, uh, vectors something. It's all I can imagine it, but I don't know how to explain in words. Okay, so embedding models are there. DALI model you can use, that you have used, that uses a description of an image and convert it into an actual image. You write a horse on a, I mean, mountain. You, it can draw that. Alien with pajamas, it can draw that, right? It's fun to play. But yes, okay, what happened? Sorry, give me a second. Okay, so, okay, no, nothing about it. So yes, these are all the models that OpenAI has made, and which are used by uh, Azure to give you more intelligent. Now I have made something for you to give you how actually this can be made with the Azure AI. I mean, I said in the starting that sometimes Azure AI scares me, right? I have made models related to machine learning, computer vision, neural network, LSTM for text analysis, sentiment analysis, and I mean, it takes some time, it takes some hardware, right? But using Azure, let me show you how easy is this. And believe me or not, sometimes I think that that I should use Azure rather than building model, because there's it is very accurate models and you can just directly use them. I mean, let me show you. This is a custom vision example. What we happened here is we just imported the necessary libraries. So what we imported is Azure Cognitive Service dot vision dot computer vision. From there we imported computer vision client. Right, this is important. And from authentication we imported cognitive service credential. That's it. So these two things we have imported. Now the thing is we just made an endpoint. So this is the endpoint is this. This is for a model that is in the Azure. I will tell you how that thing is. And I just enter my endpoint. That both things provided by the Azure. And we just pass into the credentials, the key, and the client we pass both endpoint and credential, and just connect the path takes the image, and like it creates a path for it, and just we pass it to the describe image string or bracket में we are passing the image. And if you can see in the result, it telling me that there is a person, there is a wall, it's indoor, it's a man, it's a pointing to something or something like that. So you see these, I mean, what is it like, one, two, three, four, five, six? It's literally 6 lines of code in which you imported libraries and printed result. And one thing is, and 3 lines is just handling the endpoint on the key. I mean, these just 6 lines created a model for you. How amazing that! And one thing, if you are planning for Azure AI fundamental exam, there is one thing you should know about the computer vision and the custom vision. When you train your model specifically to your design, specifically to your data set, it's a custom vision. And if you're using object detection model from Azure AI, it's an computer vision model. So here we train the model on recognizing the images of whatever the man we took on all the objects. uh, so it's a custom vision example. One thing, so okay, let's get into the second example, then I will come. What? Azure AI, what gives you is a marketplace. Marketplace is something like similar. Marketplace, market. It's a market of models. You can find different models with different accuracies on that. So it has a marketplace where you can find different model, different services. You can take it, and you just have to, train that model according to your need, and you can just train it. So if you look on the top, we added the training images in the top corner. We click the train button, and they have two features. One is quick train, and it's a second thing is a long train or something. So in quick train, it will just take like 5-7 minutes, but long train, you have the capability to train like for half an hour, 1 hour, 4 hours, something like that. So it's up to you. So we check for the quick training, and we took very less number of images, and then we check the performances. So this is the performance, like precision 100%, recall 100%, and accuracy is 100%. So when we are using the small data set, we always get a high accuracy. I will tell you why. So this is like you are using directly to the market. I took the model, I fitted all the images, and I check the performance on like random images on different images. So this is, you can see, that's how it looks, and you can just deploy it. There's some button, I guess. It's a button. You can deploy this also model in whatever the cloud you need, in a container or something. So that's pretty much about the Azure. Uh, One thing that I want to add is, yes, about let's put a step back. Um, what do you think? Machine learning came now, or it was there from like centuries or something, like from very past, right? I mean, some people think that it recently discovered, but that's not true. The first time neural network term coined was in 1990 something, right? So we have gone far. It's more than 20 years or something, and we are using techniques. So what happened is, why previously machine learning was not used, because we don't have the data. But as soon as we are moving in the modern world, we are storing all the data in our computer, right? We have a database. We have all the now. If you go into Facebook or somewhere, they have everything about you: your browsing history, your name, your date of birth, your place, everything. And some of them have their your usual daily activity, like you go in the browser, you search for it, and whatever it is. So they know what your behavior is. So similar thing is, training some model or anything requires a lot of data. And if I say ideally, 5 lakhs of rows wasn't was considered like good data. Say 5 lakhs of data. If I give you, okay, here's a 5 lakhs of data and clean it, you will say, I can't do it, man. 5 lakhs of data. How I can go in every row? But imagine 5 lakhs of data. We train a model and then ask for the prediction, right? So that's how things are. Uh, Similarly, when we gave, like here, I guess we entered 12 photos for the training. So it's a less images. It worked like RAM. Just like RAM memorize everything, this model memorize everything. So that's why we are getting 100% marks. So that's the thing. Okay. And I guess that's pretty much about the session. And anything that I can give you, I hope everyone learned something, right? Just for a quick recap, I'll just go in the starting, and we can have a later, you know. So, how amazing that you have learned about the AI, machine learning, Azure also. And to be honest, if this presentation will help you to clear your Azure AI fundamental exam, if you can search on the website AI 900 it is, you can go to it. Okay. So we learned about the AI, ML, DL. So it's more like how AI are interacting like human and all that. We learned about the machine learning. What is machine learning? Machine learning, I can give a bookish definition, is that when we don't have to explicitly code for something. For example, uh, we see that spam or not spam. example, right? So what happened earlier was that when the Gmail was there, they received different mails, right? They get to know that people are using it for the promotional things, and let's say a businessman don't want that, but people still get the email, right? You know it. So what they do is they write a code in which they mention that if we found free three times in our Gmail, it's most probably a spam email. Don't show me. But then, the person who is sending the email got to know about the strategy. What he did, he added one more free. Okay. So they changed the code. They added one more for if or one more if condition. Then he removed two free. Who thought? So here is that breaking the pattern is very easy. We want machine learning to understand on its own, machine to understand it on its own, what is a spam or what is not a spam. That's where we need a machine learning, where we can code a problem. If there's a problem, we can code its solution directly. It will take lot of conditions. So that's where we use machine learning, and we studied supervised, unsupervised reinforcement. Reinforcement is like robot. Unsupervised is when you don't have uh, teacher. You just make clusters of similar thing. And supervised learning is when you have a teacher and you can predict either a integer value, floating value, or you can classify it yes or no, right? So we use this. Clustering was also used by web developers to understand when what type of audience they are getting and what they are liking, right? Neural network is used in deep learning. This is the pipeline we studied. These are the matrices to evaluate your models, and we learned about the principle that you should have in your mind, right? Cognitive service. These are like amazing. Yeah, I mean, so these are we studied about OpenAI services. We know about all the models now, and we learned how we can code something. Like you can take a screenshot of this and you can try. But let me tell you, in Azure, you have to first create a resource pack. I mean, there's everything is written there in a very efficient way. You can see it. But this is the code. Just you can take a snip, right? And you can also find this. This is very easy. Yeah. I mean, through Azure, everything is very easy. So, thank you so much for all this. That's it from my side. Now you can ask me question if you want, I guess. And if not, let you can connect me on the LinkedIn. You can search Vishal Gupta, and it will show IUC BVP or something like. Okay, and this is the attendee survey. You can fill this out and let us know your feedbacks. Right. That's it from my side. Okay.